have a tremendous interest in the sciences. As a result of which, once I finished all my studies and things like that, which were all in the humanities, once I finished all of that, I decided to start experimenting in science. And the people who helped me best were the schools with which I was connected. Students from there would come to me and they would tell me that, sir, let's do something. And fortunately for me, I always had the time to do something. So one of the things that we developed was a very interesting situation where we could, with bamboos and things like that, and old oil drums, make a windmill. We made a windmill with an oil drum, and it was not the normal kind of windmill which goes round and round laterally. It was one which went round and round on a single axle. This is called a drum windmill. That's why we were able to make them with oil drums. And please, they didn't open a single book to do this. They did this with their own capability, their own what we call scientific temper. People need that, and children have that. Every single child wants to know why. Every single child wants to know how. We should give them the opportunity to understand why and know how to do it.
It all begins with observation. It all begins with identifying problems. It all begins with daring to question. And when you do that, I think, you will be scientists and you will be innovators, in your own right. And, I don't know if there are any teachers, but, I would only like to say this, that, give them scope for this. Never be in a hurry to say that this is the curriculum that we have and we've got to cover the syllabus. Instead, I think we need to help children discover the syllabus. And we don't need to teach everything to the kids. We need to help them learn. So then, our jobs become a little different. It becomes creative for the children, and the outcome would be far superior to what is happening in current system. I'm sure there are a lot of experimentations happening, and, I would like to commend the young team for, coming up with this beautiful project. I think I like the thought behind the entire thing. I know that implementation will take a little while, and people have to start believing in it. But I think, you kids sitting here are the brightest brains ever. You just have to believe in yourself and, go for it. And I'm sure that one day you'll look around and you'll turn around and you'll say, yeah, I think I decided to become a scientist or start creating. And the other thing is that you don't really need to be a scientist to innovate. It could be done in any field. So, the only thing is that the method that is being followed, what we call as the scientific method, I think should be followed in all sectors. And I'm sure that wherever there's a need, then there would be, there is the need, then you start creating. So I think that's the best thing that can ever happen. So I think what we're going to be doing, I think, is look around, observe, see where the problem is, and go for it.
Academics is nothing but what is around you and how you creatively get into the child's brain and how happy this child is in that environment. And that's when he comes out with his new ideas, and once that new ideas and when he feels belonged and when he feels leadership qualities for this act of whatever he does, and he opens up in various concepts. How we can develop this? By letting them free, or giving them an opportunity to create what is in information. Today, information is farce. Everywhere we have information. We have to tell the kids how to use the information, where to use and when to use. Today's education, we have to create this enthusiasm.
I just wanted to connect this need for scientific temper, methods of research, application, all of that. The education sector in this country requires really strong. I mean, I can excuse myself, but all the people here, the best people with the best minds, best talent, really committed to the teaching profession and the learning profession. I think teaching profession is one of the most noblest in terms of contribution to the GDP of the country or the potential of the child. I think we should just elevate that profession a little more, professionalize it a little more, increase the level of interest, not just from the government or policymakers or experts who are giving recommendations, but also from the societal demand standpoint for more quality teaching. I think there's a huge mindset shift that we require, and I would actually, when we see Tarun, he is so excited about science, and that level of passion is required for the teaching profession today. And certainly I would like to urge all parents to consider and explore how do you bring in better quality learning in classrooms and at homes. And that's where we also have to challenge ourselves. How do you build capacity amongst ourselves for better learning, not just from the children's standpoint, but also as parents and as society at large with regard to the profession of teaching.
There have been many tales of people who have been time travel again. So there is one of a king in Mahabharata series called Revathi who has actually traveled to heavens, and when he came back he found that many ages have like left away. And there was another famous Japanese tale of Urashima Taro who has saved a turtle and was invited by the sea goddess for a 3-day trip, and after he comes back he found that 300 years have passed away. If you travel fast in the speed of light or almost near to the speed of light, the time on earth will double than the time you experience on the spaceship. So actually what is happening is the gravity is trying to pull your time. The second one is black holes. So black hole is actually, when we revolve around the black hole, we find that the time has been reducing due to the internal gravitational pull of the black hole, and when we observe it will take for us only 8 minutes for a revolution, but for the observer it will take 16 minutes. The third one being the wormholes. Wormholes, what actually do is they connect two very far distant places together. So they just bend the space or even the time, like it points of time, and you get in through something and you get out through a point which was nowhere connected. So it is like teleportation. As we can travel to past, we can also travel to future using two methods. One is time dilation and another one is time perception. So time dilation is actually a process in which we can observe. See, now if I am talking here, we can hear a sound from here, and after a fraction of seconds we hear a sound even there. So there will be at least some fraction of seconds difference between here to there. Basically what we see is our past, because the light takes a little time to travel from your side to our side. So it like at least 1,000 of the billionth of the millionth of the millisecond. So there's another theory also called time perception. It is actually related to psychology or neuroscience, in which if a person sleeps for 5 hours, he experiences just as 5 minutes. So he may have a like psychological disorder, which is considered to be time traveling by many of the scientists, but it is not actually proved.
Close to the speed of light, mass turns into energy, so you won't be time traveling, you'll just be getting yourself turned into energy. That's the first point. And second point, if you're talking about the black hole, then as you revolve around the black hole and approach the singularity, you will be ripped apart molecule by molecule.
You're not actually approaching the speed of light, because if you approach the speed of light, the time will completely stop for you. So you're not traveling into the future. If you travel faster than light, it's well and good, you can go faster in the future. Otherwise, you might only go twice the speed of the time on the earth.
When I mean you approach the speed of light, you are at the speed of light, a power of 10 behind the speed of light,
no,
or anywhere ahead of speed of light, you turn into energy.
Yeah, that is what is related to quantum mechanics. Quantum mechanics actually deals with the spaceships and all are designed that way that the energy that reacts with the things which we made, like these spaceships. So according to that, the models are created, and then like the speed that can be resisted. The conversion of molecule into energy can be resisted. Even FTL method, this was actually proved by NASA government.
What we should take a theory on. We went through so many things. We thought let's have some humor, delve into the comics world, explain something about the comics. But then Ansh suddenly struck out with an idea, saying, why are we delving into such childish things? Let us do something on a larger scale.
There's no supernatural phenomenon happening there, no UFO sightings, nothing. It's just simple science. Thank you.
We like to believe that there's nothing which science can explain. Everything supernatural, even considering magic, if it is real, is basically science which we do not understand.
We are just trying to give our own explanation. We just want to show that anything is possible. What they are saying, we never said that they are wrong. But all this, what we are saying, that is possible. That might be a possible explanation to what is happening at that point.
So your theory might be right or wrong. So you only don't have like an explanation.
Theory is experimenting, and theory might be wrong or right, but we are experimenting on that, and we tried to do it by actually thinking about those possibilities. We thought about it.
5 minutes presentation. In this, I'm going to discuss. We are going to discuss about experiments we have done and observations we have done.
Experiment 1. Keep the finger in the ant hill. You get that ants stink our finger. Why? Because they want to protect their food. In day 1 we have done this experiment.
The second experiment is if you we said that ants leave secretions which are followed by the next ants, and if you erase the secretions, you can see the ants are confused. So by this we can say that ants totally depend on these lines.
As in third experiment, we had tasted the liquid which was released by the ants. It was sweet. So we have declared that is the mixture of starch and sugar.
And the third experiment is we had in this experiment we have simple things like pencil. We took a ant on a holder, and we just rubbed the pencil stroke on the butt of the ant. So after that we draw that line on the paper, and we sent a group of ants. These ants moved in a line which was drawn by us. So therefore we conclude that ants actually move in lines to protect their food and themselves, and to protect their team members, and to just protect the families, and make a better future, just like humans. And they do work with discipline. So we should learn from them a lot of things like hard work, discipline, etc. Thank you.
Looks like we are ready for the duck duck moments. So yeah. So do you want to join in and say duck duck?
Any guesses which team made it?
I think let me congratulate everyone. You have done an excellent work. In 2 minutes, presenting the whole thing is very difficult. I think you tried all your best. So whatever we are judging is based on what we understood in the 2 minutes. So probably it's also a judgment on ourselves, how much we understood what you said. One of the teams is already announced, the Bermuda Triangle. You have done an excellent work. Second team picked up a simple theme but presented it very well on the ants, the bright minds. The third team, I think audience made the choice. It's time travel.
When we talked earlier about research methodologies and various ideas in innovation, I wanted to share a story with you to make you understand how important it is to have innovative capability. Now, innovative capability comes from several ways. There was a young fellow who went to the University of Copenhagen in Denmark. He sat for his examination in physics and he got 100% in it. There was not a single mistake in his work. So the examiner had a look at the paper and he said, oh my God, this is impossible to get 100%. He must have cheated. So the student was called. And when the student was called, he was asked, have you cheated? So he says, no, I have not cheated. He says, but it's impossible to come with 0 mistakes in a physics paper. So he says, well, you can test me. And in any case, the teacher failed him. So he appealed to the university and he said that how on earth can he fail me? What was the issue here? And then he was told that yes, he's absolutely right. There is no evidence that he has cheated. So what we can do is to give him an oral examination to see how well he can do without preparation. So an external examiner was called. When the external examiner was called, the external examiner called the old teacher and asked him a question related to physics. And then this gentleman said that, okay, this is a barometer. How will you tell the height of this skyscraper with the help of the barometer? Now the student kept quiet. And so the external examiner said, look son, you've got 5 minutes to answer this question. Think about it. So the boy thought. And for 4 minutes he didn't say anything. Then the external examiner said, look, you've got only 1 minute left. Surely you can tell me how to find out the height of the skyscraper with the help of a barometer. So he says, yes, actually I've got a lot of ways of finding out the height of the building with the help of the barometer. I was wondering which one to use. So he says, okay, try us with one. So he says, that's very simple. I'll go to the top of the skyscraper with the barometer in my hand, and then I will just throw it off the top of the building, and the time how long it takes to hit the ground. And using a simple mathematical formula, I can tell you the height of the building. So the external examiner says, is absolutely correct. But the internal teacher said, no, but that doesn't show that he knows any physics. So he says, no, then give us another solution. So he says, it's not a problem. What I will do is I will put the barometer on the sidewalk, on the pavement in front of the building. And if it's a nice sunny day, I will see how long the shadow of the barometer is. And I will also see how long the shadow of the building is at the same time. And through a simple arithmetical process, I can tell you the height of the building. Again, the answer was right. But the examiner said, no, but this is not the kind of answer that we wanted. So he says, okay, if you want another more scientific way of doing it, tie a short length of string to the barometer, and I will swing the barometer from side to side. And looking at the angle and the time taken in the swing, I will also go up to the top of the building and swing the same barometer with the same length of string. And through a simple arithmetical process, by the variance of the swing, I can tell you the height of the building. They said, no, that's not the answer that we wanted. So the man said, okay, since it's a skyscraper, it must have a fire escape on the outside. So first thing I will do is to measure the height of the barometer and then walk up the staircase on the outside, measuring how many barometer sizes it goes all the way to the top, add it all up, and I can tell you the height of the building. So he says, no, wait, that's not the answer that we wanted. So he says, okay, in that case what I will do is I will tie a nice long string to the barometer, measure the height of the barometer, go to the top of the building and lower the barometer from the side, and I will measure the string and the size of the barometer, and I can tell you the height of the building. So he said, no, but that's not the answer that we wanted. Although it's an accurate answer, it's not the answer that we wanted. Please note that he's already given 6 correct answers. So he says, no, but please tell us how we can use the barometer. So he says, okay, if you want to do it in a boring old fashion, I will measure the atmospheric pressure at the bottom of the skyscraper, then go to the top of the skyscraper, measure the atmospheric pressure over there, and working out the difference of the 2 atmospheric pressures, I can tell you the height of the building. but there's a much faster and better and a more accurate way of doing it. So they said, yeah, what is more accurate than this? He says, it's very simple. I will take the barometer and I will go to the custodian of the building, knock on his door and say to him, look, if you tell me the height of the building, I will give you this barometer. This young man was finally passed, of course, because they gave the answer that the institution wanted. Not because he gave so many answers, but because he told them about how to use the barometer as measuring the pressure at the bottom and the top. This gentleman went on to become the only winner of the Nobel Prize from Denmark, Mr. Niels Bohr. Scientific temper comes from inquiring beyond what the question asks, from finding out where the idea comes from, finding out more ideas to do the same thing. That is what research is all about. That is what inquiry is all about.